Alright guys, so what I want you to do first is just write down the definitions of these four terms that correspond to the notes that you have, and just start the video when you're done and I'm going to talk about them. Alright, so what we're going to look at today is this idea of polynomial functions. And a polynomial function has some form like this. So all that n represents are non-negative integers. So like this represents like a coefficient of whatever this power is, which is like a 3 or a 2 or a 1. And all of these are in descending order, which we'll talk about in a second, called standard form. So in each of these, in this whole polynomial function, there are three key things. There's a leading coefficient. A leading coefficient is a coefficient that belongs to the variable raised to the highest power. Okay? So like in this example, this term is the leading coefficient. Whatever that is, that's my leading coefficient because n is my highest power. Okay? Now there's also a constant term, and that's the term that does not have a variable attached to it. Okay? So like that would be right there. And the degree is the highest power. So let's look at this function right here and identify what is the highest power. Okay? So that means my degree in this case is 7. Alright? Well, the next thing I want to identify is my leading coefficient. So my leading coefficient is the value that's in front of my highest power. So in this case, my leading coefficient is 3, and then my constant term is negative 3 because negative 3 does not have a variable next to it. All right. Now, write this down for standard form. It's a polynomial function is in standard form if its terms are written in descending order of powers from left to right. And one of the reasons that we do this is so that we can identify like what the type is. So you have this little diagram here, and we have this thing. Whenever the highest power is 0, that's going to be considered to be a constant term. So that tends to be like a horizontal line. All right, that tends to be a function that's a constant. A linear function is when the highest power is 1, or the degree is 1. So that tends to be like like some sort of oblique line that's kind of angled. Then we also have quadratics when the highest power is 2. We know that that's going to be like a parabola. Then we also have this thing called a cubic. When the highest power is 3, it's considered to be a cubic function. All right, and we'll deal with what those look like in a little bit. Now there's also a quartic function, which is when the highest power is 4. So let's look at some examples here. So what we're asked to do is decide whether the function is a polynomial function. If it is, write the function in standard form and state its degree, type, and leading coefficient. So when I look at A, we're looking at this one first. In order for it to be a polynomial function, all the exponents first have to be non-negative integers. So when I look at this 1/2, is that a non-negative integer? All right, is it something that I can count with? No. So this is not a polynomial function. Okay, not a polynomial. So let's look at B. Well, is this a polynomial function? Well, imagine that there is a power, but it's just x is being taken to the 0 power. Okay? So this is a polynomial function. In exact, it's a 0, so it means it's a constant function because my degree is 0. Now, I know the type is constant. It is in standard form. And the leading coefficient there, we could say that the leading coefficient is 3 because there 1 there. So let's look at this one. Is this a polynomial function? I do not care about this number. All I care about is what is the variable taken to, and this variable is taken to the first power. So what I want to do is rewrite this in standard form, which is going from highest power down to the lowest power. So negative x plus square root of 5 is standard form. My degree is 1. And then that means the type is linear. And my leading coefficient is negative 1. So what I want you guys to try to do is try these 3 problems, and we'll go over them in class tomorrow. Thanks for listening.